Hi everybody. Today's lesson is 5-7, adding and subtracting unlike fractions. By that we mean adding and subtracting fractions that don't have common denominators. Well, we talked a little bit earlier about requiring fractions to have common denominators in order to add them. We've done that before. But in the previous lesson we talked about the least common multiple, the lowest common multiple, and we also talked a little bit towards the end about finding the least or the lowest common denominator. Well, if we can do that, and then we can realize that once denominators have the same, once fractions have the same denominator, we can add or subtract them. We're going to bring all of those ideas today and see what we can do with them. All right, let's go ahead and get started. So we'll start here. If we were asked to find 1/4 plus 2/3, I can't add these because they don't have common denominators. The denominators aren't the same, so these fractions aren't like. So I can't add them yet. So what I need to do, I need to build these fractions to equivalent fractions, fractions that have the same value, but that have the same denominator. So I can do that by finding the lowest common multiple, the least common multiple of these denominators would give me the lowest common denominator, and the lowest common denominator of 4 and 3, you may have already guessed it, is going to be 12. So the LCM of 4 and 3 is 12. So what I can do is I can build these fractions without changing the value, so I can build them to equivalent fractions, okay, fractions that have the same value, just look differently. And the only way I can do that is by multiplying by 1. So what I can do is I can take this 1/4 and multiply by 1. And I can take 2/3 and multiply by 1. And I just need to choose a version of 1 that would suit my needs. Remember, there's an infinite number of ways to write the number 1 because anything over itself equals 1. Well, if I want to build these fractions to an equivalent fraction with a denominator of 12, I want to build this 4 up so that it's a denominator of 12. I can do that by multiplying 4 times 3. But I cannot change the value of this fraction, so I must multiply 1/4 by the number 1, and I'm just going to choose 3/3 as my version of 1, because now what I've got is this fraction. Remember, multiplying fractions, I multiply the denominators, 12, multiply the numerators, 3 times 1 is 3. Notice that 3/12 and 1/4 represent the same value. In fact, 3/12, if I were to reduce it, take out a factor of 3 on the top and a factor of 3 on the bottom, I'd be left with 1/4. So this has the same value. Why do I want to do this? Well, watch what happens if I build this fraction to a equivalent fraction with a denominator of 12. How do I build 3 up to 12? Well, I'd multiply by 4. I can't multiply by just 4 on the bottom. I have to multiply by 1, so 4/4 equals 1. So now 2/3 built as an equivalent fraction with a denominator of 12. 3 times 4 in the denominator is 12. 2 times 4 in the numerator is 8. Now these fractions are like fractions because they have a common denominator. Now I can add them. 8/12, if I were to reduce it, it would reduce to 2/3. So now when I add these, 3/12 plus 8/12 gives me 11/12. And there's my final answer. So I have to have a common denominator in order to add or subtract fractions. Let's try another example. Now, if I were asked to find 3/8 plus 7/12, I can't yet compare these fractions. I can't add them yet because they have different denominators. So I need to build these fractions to equivalent fractions that have a common denominator, the same denominator. Now, I can always, here's a little trick, I can always find a common denominator of 8 and 12 by multiplying 8 and 12 together. You can always find a common denominator by just multiplying the denominators together. But what's going to be more beneficial for us is if we can find the lowest common denominator. And remember, the lowest common denominator is equal to the lowest common multiple of the denominators. So the first denominator is 8, the second denominator is 12. 8 is 2 times 2 times 2, which is 2 cubed. 12 is 4, which is 2 squared times 3. Take the highest from each column, so the lowest common multiple, which turns out to be the lowest common denominator, is 2 cubed times 3, which is 24. So what I can do now is I can build these fractions to a denominator of 24. Well, how do I build 8 up to 24? Well, I multiply by 3, because 8 times 3 is 24. And I can't multiply by 3. I have to multiply by 1. So I'm going to multiply by 3 over 3. So my new numerator here, 3 times 3, is 9 24ths. Plus, well, I need to build this denominator of 12 to the common denominator of 24, so I'm going to multiply by 2, but I need to multiply by 1, so I'm going to multiply, in fact, by 2 over 2. So there's my new denominator of 12 times 2 is 24, so my new numerator here is 7 times 2, which is 14. Then I just add these together, and I get 9 plus 14 24ths, or 9 24ths plus 14 24ths means the same thing, and that is equal to 23 24ths. Once you get the hang of this, I don't think you find it that difficult, but it does take a little bit of practice to make sure you understand it. What about a challenging one? 1 2/9 plus negative 2 1/3. Well, how do I deal with all this? Well, I'll tell you, this is yet another reason that I like improper fractions much better than mixed numbers. So I'm going to first convert these into improper fractions. So 1 2/9 is the same as 11 over 9, plus negative 2 1/3 is the same as negative 7/3. So now I need to recognize that I can't yet add or subtract these because they don't have a common denominator. So you're going to get the hang of these pretty quickly, that sometimes, hey, the common denominator, lowest common denominator between 9 and 3 is going to be 9, because I can build 3 up to 9, and 9 is already 9. I could find a common denominator by multiplying 9 times 3 and getting 27, but that won't be the lowest. So we're going to try and find the lowest common denominator. So if I take this second fraction and just multiply by 1, and the version of 1 I'll choose is 3 over 3, I get 11 ninths plus, how many ninths? 3 times 3 is 9. Negative 7 times positive 3 is negative 21. So I have 11 ninths plus negative 21 ninths is, right, hopefully you got that, negative 10 ninths, because I just look at the numerators, because the denominator's the same. 11 plus negative 21 is the same as 11 minus 21. And if I take 21 away from 11, I have negative 10. Subtracting fractions work very similarly. If I have 5 21sts minus 6 sevenths, you may be able to tell that I can build these fractions to equivalent fractions with common denominators. 21 is going to be the lowest common denominator, and I can build the second fraction to a common denominator, equivalent fraction with a common denominator of 21 by multiplying by 3 over 3, because 7 times 3 is going to give me 21. So now I have 5 over 21 minus 7 times 3 on the bottom is 21. 6 times 3 on the top gives me 18. So I have 5 21st minus 18 21st. Remember, the denominator stays the same, and I just subtract the numerators. 5 minus 18 is negative 13. Okay, again, more practice you get with these, the more efficient you're going to be able to do them. Last example, and I'll cut you loose. 6 1/2 minus 4 1/5. I don't want to compare these like this or subtract them like this, so I'm going to turn everything into an improper fraction first. So this is 13 halves minus 21 fifths. Well, I need a common denominator between 2 and 5. Hopefully you can see that if I multiply 2 times 5, that will give me a common denominator, and in fact 10 is the lowest common denominator. So what I'm going to do is I need to build the first fraction to an equivalent fraction with a denominator of 10, and I can do that by multiplying 2 times 5. So I'm going to multiply by 5 over 5 because I can't change the value of 13 halves. The second fraction, building it to an equivalent fraction with a denominator of 10, I'm going to multiply by 2 over 2. Now I can just do this calculation, and what I get is 65 over 10 minus 42 over 10. Now I'm dealing in tenths, so I can say, well, that's 23 tenths. Well, where's 23 tenths on the number line? Oh, well, you might be easier to find if you say, well, 23 tenths is 2 wholes, and 3/10 left over. Okay, 2 and 3/10 is a little bit easier to find on a number line. Both of these are acceptable answers. Okay, I don't think you're going to find this challenging. It just takes a little bit of practice, and you've got to get that mental muscle memory going. All right, guys, that's it. We'll see you next time. If I